this tutorial, I will be showing you how radars use sphere coordinates to give us the x, y, and z coordinate of an object. And I will be showing you how you can use Python to graph 3D objects. In our previous video, we had a scenario where our enemy's cannon fires a cannonball into the air. We use our radar to retrieve the coordinates of that cannonball during 3 short intervals of time. We get point 1, point 2, and point 3. How does the radar get the xy coordinates of these points? Here we have this radar in this sphere coordinates, and it's on 0, 0, 0. Here we have the cannonball. First, the radar will detect the distance between the cannonball and the radar. Here we have c, which is the speed of light. The distance equals to the speed of light, the speed times the time. But since the signals have to go to this cannonball and then return back to this radar, it would be the time, delta time divided by 2. So it's speed of light times the time divided by 2. And the time is the time it takes for signals to reach the cannonball and return to the radar. So now we have the distance here. Now we want to find the angles. The first angle will be alpha. It's like this. Here we have this z-coordinate. Here we have something like a door that revolves around it. When it's closed, it will be here. We open it all the way until it's opened alpha degrees. So we get alpha. And then, from the bottom of this door to this cannonball, we measure the angle here. We get phi. Here I have the set of equations. We know that the distance should equal to x squared plus y squared plus z squared square root. This angle here equals to the tangent inverse of y over x. So here we have y and x. And phi equals to the sine inverse z over square root of x squared plus y squared plus z squared. But we have the sphere coordinates already. What we want are the x, y, z coordinates. So with the information here, we can switch it up and get x equals to this, y equals to this, and z equals to this. Now, here we have a picture of the Earth. This is the center of the Earth, and let's see. Here, alpha is actually the longitude, and phi is the latitude here. Here is our point where we want to detect. So they will give us, we have the radius of the Earth, we have the angle here, and the angle here. Let's see. Now, what if we want to find this point here where the angle is 30? This is the Earth, and the longitude is 30 degrees, and the latitude is 45 degrees. The radius of the Earth is approximately 6,360 kilometers. So we substitute that all into our equation here. Here we get the x, y, z coordinate of this point. And this is the sphere coordinates of that point. Now, in a GPS, this is something they will give us. Here we have the latitude. Here we have the longitude. This is the elevation. This here does not equal to the distance from the center of the Earth to our point. The elevation is how much is elevated above sea level. So if we want r, we have this number added with the radius of the Earth. this is in feet, so we'll have to convert this to kilometers. Now let's have a look at our Python program. Here, I will run this program. Here we get our result, only that here is more accurate. We can simply find the integer value if we want. Now, if I run this, here's the result we get earlier. First, I define r. This will be the radius of the Earth. And we can choose the degrees here. I say alpha is 30 and phi is 45 degrees. From the math module, I import sine, cosine, and radians. From our formula here, we have x equals to r times cosine phi times cosine alpha. So we have r times cosine. Here I want to convert this degrees into radians before I put it inside the cosine. So I have this radians here. I put in the degrees, and here I also convert the alpha into radians. I do the same thing for the y and z, and I print them. So we can change this 30 to 50 and see what we get. Here we have these different results. I can change this into an 80. And here we have these. What if we have the x, y, z coordinates and we want to find the sphere coordinates? Let's run this. Here we have the sphere coordinates. Let me first turn them to integers. Here we get these. Now, in our picture here, we have the r equals to this, so I put it into our Python program. Alpha equals to this, and phi equals to that. So over here, I have r. ATAN stands for tangent inverse. Here I have y over x. Here I have sine inverse, and I input that and all those things. Finally, I print them. But since this will only return the radians, I want to convert them into degrees. So I import the degrees module. I import degrees from the math module, and I print out the degrees of alpha and phi. Now let's see how we can graph something. Graph a 3D object. Here I have this. We have something like a book. From mpl_toolkits.matplotlib, import access3D. Even though we don't call this in our program here, simply importing this will give us this 3x3 graph. From matplotlib.pyplot, I import this as plt. Now fig equals to plt.figure. It will give us this figure. Here I have fig.add_subplot. Here I have 1, 1, 1, and projection equals 3D. Now it's time to plot the x, y, and z's. So the first one here, and the first one here, and the first one here will be a first plot. I plot them at 0, 0, 0. So that would be at this point. So the next plot will be 0, 0, 1. That means the x and y will be 0. So let's see. But the z will become 1. So that will be this point. Then I want to go here. Over here you can see it's x equals 0, y equals to 1, and z equals to 1. Let me first simplify this. First I have just 1, they're all at 0. Now I can change this to a 3. That will give us 3 for the x coordinate. Now we have this line here. Now I want to change the I want to make a turn at it. Now the y will equals to 3. And the z will remain 0. Now we see this. What if I don't want the z to be 0? I want it to lift up. So z equals to 5. Now, this, you can see this is like lifted up a bit. Finally, let's say x equals to 0. Let's see. Y equals to 9. And z still equals to 5. Now we get this. So you can play around with this and plot the shapes you like. This is the end of this tutorial. If you have any questions, requests, comments, or suggestions, please leave them down in the comment sections below. Please subscribe to my channel. It's called NetsEDU. Today is January 31st, 2020. Thank you for watching. Please hit the thumbs up button if you enjoyed this video. Have a nice day.